Welcome once again. In previous video, we have studied the common source amplifier. We should note down that to achieve a high voltage gain with limited supply voltage, the load impedance must be as large as possible. Why? Because AB is equals to minus GM RD. So, this is our output impedance. Now, to drive a low impedance load by common source stage, we have to place a buffer after it. Why so? Because buffer will not affect or decrease the gain of common source stage. In this video, we will study the common drain amplifier and which is a MOS buffer. It is also called as source follower. This is the circuit diagram of common drain stage. It senses the signal at the gate and drives the load at the source and drain terminal. This drain terminal is common to both input and output ports. Now let's focus on its input output characteristics. Here for when the V input is less than the threshold voltage, then this M1 transistor is off, so V out is 0. Now as V in exceeds the threshold voltage, in this case M1 turns on in the saturation mode and the drain current flows through this resistor Rs. Now as V in further increase this V in, what happens? The V out follows the input with the difference equals to this VGS. Here the drain current is given by half mu n Cux W by L VGS minus VTH whole square. Okay. Now what is this VGS? VGS, you can see the gate voltage is V in and the source voltage is V out. So we can write VGS is V in minus V out. So using this VGS in the equation, so the drain current is, let it be Kn dash, this half mu n Cx W by L can be written as Kn dash. So I will write V in minus V out minus this threshold voltage whole square. Now what is the V out? Here you can see that V out is given by ID, that is drain current product Rs. This drain current is flowing through this Rs resistor. So V out is simply their product. So using this drain current equation into this one, we get half mu n Cx W by L, that is our Kn dash, and V in minus V out, just writing it in this way, V in minus VTH minus V out whole square product Rs. So this is our V out. Here you can see that V out, which is the source potential, this is our source potential and is following the input voltage, which is the gate potential. Therefore, the common drain stage is known as the source follower. Now moving ahead towards the small signal analysis. This is the small signal model of the source follower. Here we have considered the substrate bias effect and its transconductors GMB. So let's write all the equations from circuit. We can write from this circuit V in minus V1. I will use this space, V in minus V1. V in minus V1 is equals to V out. Okay. So this is our equation 1. Also this V out is minus of VBS, the substrate bias effect voltage. So VBS, this is our equation 2. Now applying the KCL at this source terminal, so we have V out upon Rs, this current V out upon Rs, it is equals to GMV1 plus GMB VBS. Writing it GMV1 plus GMB VBS. So this is equation 3. this VBS. Okay, so V out upon RS. VBS is what? VBS is minus, sorry, I should write it as GMB. So GMB V out. VBS is V out minus of V out. Okay, so this is equation 4. Now next part, and again substituting the value of V1. So we are using the V1 from equation 1 into this equation 4. So again writing the equation 4. So it is V out upon RS, yes, and then GM, the value of V1 from equation 1, it is V in minus V out, and rest part is G minus GMB V out. Okay, so now taking all V out at the same side, so writing it V out, taking common 1 upon RS, then this will be plus GM plus GMB, and at the right hand side it is GM V in. So our voltage gain is V out upon V in, GM upon all these factors. So this is our voltage gain. So rewriting this voltage gain, here this GM plus GMB product RS, it is obviously very greater than 1. So we can ignore this 1, and in that case it is GM upon GM plus GMB. Yes, and this eta is what? This is GMB upon GM. So as the input voltage increases, this eta will decrease, and the voltage gain would eventually equals to the unity. However, practically the eta remains greater than 0.2. So we have always voltage gain less than unity. So we have seen that the common drain amplifier has almost unity voltage gain. It has high input impedance. Why? Because input is given at the gate terminal, and its output impedance is very low, given by this 1 upon GM plus GMB. Here you should note a very interesting point, that this body effect decreases the output resistance of the source follower. So this is all about the basics of common drain amplifier or the source follower. In the next video, we will study about the common gate stage. If you like this video, then please share and subscribe the channel. Thank you so much and have a nice day.